Hey everybody, it's Mr. Allred. I'm going to talk more about integration. So we're going to now talk about the integration of the exponential e to the x and what will become the natural logarithm function. So just a quick review, you may remember that if you took the derivative of e to the x, you got e to the x. That was one of those fun little derivatives. So it's no surprise that if you took the antiderivative, you get the same thing. Also, you remember if we took the derivative of the natural log of x, we got 1 over x or dx over x. So the antiderivative or integral takes us back. Both of these have a plus c on them, remembering that anytime we take an antiderivative or an integral, an indefinite integral, that we get that plus c because we don't know if there was a constant there or not. So these are pretty boring by themselves. And they're still going to be boring on this page, but just to spruce them up a little bit, let's remember some of the rules that we've already had. The reverse power rule, the sum or difference rule, which allows us to integrate two things that are a linear combination separately, and the constant multiplier, which basically means if there's something in front of a function you can integrate, then that number just stays there. Okay. So let's just see two very quick examples. So the first one here, we're going to try and take the integral of 3x squared plus 6 over x minus 4 times e to the x. So since this is three things added or subtracted together, we can take the integral of all three parts separately. So for the 3x squared, we'll reverse the power rule. So it increases to 3, the exponent does, and we divide by the 3, the coefficient cancels out, so we just get x cubed. The 6 over x. So if you separate that and pull the 6 to the side, the 6 can be a coefficient, and it's 6 times 1 over x. So if we can use that constant multiplier rule, that means that the 6 just stays there. And then the integral or the antiderivative of 1 over x is the natural log of x. And those absolute value bars do need to be there because you can't take the logarithm of a negative number. So if you were to plug a negative number in, that ensures that you can get a value back. Okay. And then the last part of that, the negative 4 e to the x, well, the negative 4 is just a multiplier, so it can stay there. E to the x integrates to e to the x. So we can do all three of those parts separately, and then we throw in the plus c, okay, for the constant that could be there. The second one here, I've got a definite integral that runs from endpoints of 1 to 3. Only two parts now, 3 over x minus 2 times e to the x. So once again, 3 over x, I can pull the 3 to the side and make it a coefficient, and then 1 over x becomes natural log of x. So I've got 3 natural log of x. And then the negative 2 e to the x stays the same because the negative 2 is just a coefficient that stays there. E to the x is still e to the x. So now that I have that, 3 natural log of x minus 2 e to the x, I can plug in the 3. And when I plug in the 3, I get approximately negative 36.88. And then I'm going to subtract off what happens when I plug in the 1. When I plug in the 1, I get negative 5.44. So a negative subtract a negative means that last part is going to be added, but it's still negative because the bigger number is negative. So I get negative 31.44. So one thing to keep in mind here is these rules are very simple. If you remember when we first started taking derivatives of the natural log or the e to the x, we just had that very simple rule. And it wasn't until we got to the chain rule that we could see a lot of variation and deviation. So pretty soon we're going to look at what undoes a chain rule so we can look at things that are a little bit more complicated. Thank you.